Clinically, good afternoon, heroes and heroines, and welcome to Practising Programming in C. It has been a hell of a long time since the last programming stream. I didn't do a single one at all last year, I saw. So yeah, it's going to take a bit of time to get back into it, I guess. And it might be a bit disrupted as well, actually, because there's stuff going on. There's work, as you might be able to hear some drilling going on. Possibly one of my neighbours might come past as well. Shortly, I'm not exactly sure when that might be. So yeah, anyway, there could be some disruptions, and yeah, I'm also only in one of the chats here. I'm only in the Twitch chat. I'm not in the HMN one for some reason. I can't connect to this, but it doesn't matter. So yeah, what I'm going to do today is just learn how to do some threading. And I think for starters, I'm just going to motivate this bit of learning. So currently, I've got this program here, Cinderella. I'll just run it, but it's not really connected to the other things that I have got going on. But this is the program that basically ingests indexing files and currently produces HTML files. Now, I've recently been working on a thing called ref store. Yeah, so it's a reference store basically. It's a reference manager. So that's there running like that. And in addition to, so that's like the server, okay. And then in addition to that, I've got, what is it? I've got this sort of thing. So this is a client that connects to the server, and you know, it displays what's on it. And you can do other stuff like what is it? You can relate things, yeah. This isn't complete, by the way, and you can't actually add any new things in here. You can create relationships between things, but you can't actually add things. I've got another client which does that. I'll just quickly show you that. So this is going to be client hard-coded. So this is like a sort of programmatic, a sort of non-interactive program that interfaces with the reference store. So this is how I've actually added everything. You can see they've got this, this ref store add author. You add the person, the person's name, the sort name, and then this is the disambiguator, basically. So if you've got multiple people with the same name, then you can use this to disambiguate between the multiple people. But yeah, anyway, so you can sort of see that in these programs, that where was that? Yeah, so you can see that in these programs, there's like one program over here which is Cinderella. There's one program over here which is the reference manager, and then you've got a third program here which is the interface to obviously control the reference manager. And basically, the whole point of this threading business is to try and make all these things go in one program, basically. I sort of initially thought that it'd be worthwhile having a separate reference manager from Cinderella, because the basic reason was that I thought it'd be worthwhile having like one reference manager that sits there containing all of the references that you'd want to use, and multiple instances of Cinderella would then be able to kind of talk to this thing and get its information from it. But I've kind of realised that you could actually do that with Cinderella itself. For a start, you could have Cinderella being just a reference manager, basically. But additionally, I kind of thought that it'd be kind of easier for a new person to like install. You know, like if they're going to be using Cinderella, it'd be easier to install just the one program and to control all of the related things to do with it if it's all in one program, basically. So this is the motivation for learning how to do threading. It's essentially to get these three things together. And I mean, I think really the two things that it really kind of needs the threading for is for what it's looking out for. So this is looking out over here. Cinderella is looking out for file system changes, like files being changed on the system, and this thing is looking out for user input, basically. And I think that you probably need to thread those two things because I think this one in particular, the user input one, actually, I think it blocks on reading or something like that. So you sort of need to do that on a separate thread. But anyway, I'll work out the details as we go and suss out exactly what we want. But for now, I think it's just worthwhile just starting on with it to see what we can do about the threading at all. So let me just close these things. I'll just close that. Goes back to PPIC. And let's start a new file, threading.c. And also let's just get some music on. Just check that the stream is still up. I think it is, yeah. Recording 8 minutes. Seems to be coming through. The video seems to be there. So, I think what I need to include, is it Pthread? Yeah. That's a good start. So yeah, I haven't actually done this, haven't written any of this before. All I've done is, I did look at an article which kind of explained what you need to do for threading. So I'll just sort of see if I can remember any of that. Is Pthread create? I think that might be the function. Too few arguments. Okay, so it's at least known to be. I think. Yeah, as I say, I think I'll just see what I can remember. Oh, there we go. So now it's showing. Compile them with Pthread. Okay, so I need to also do that. See, I'll see what I remember. See if it all kind of aligns with my kind of understanding, and then I guess we'll just sort of take it from there and see where we go. So yeah, I think Pthread create is the first thing I need to do. So I want to. Let's also make it. Let's just do Pthread up here. I think it's Pthread, wasn't it? So here we go. We've got a Pthread, we've got a thread. So I think. We've got thread attributes. We got pointers to a function, and then we got arguments to that function. to Pthread T. Might actually be handy to have this up in another window. There we go. Also, I'm using a new sized font, so we'll see if I get sick of that actually. Yeah, so what kind of attributes actually could there be? You initialize it using Pthread attribute initialize multiple functions. I mean, we can use null attributes, so I guess that might be okay. Okay, and then we're going to need a function, so this build, no. Where's that? So thread A stuff. Incompatible function pointer type. So it needs to take a void star, is it? No. Let's see about this. That's a bit awkward, it doesn't actually reline that out. The new thread starts as you're invoking start routine. Arg is passed as the sole argument to start routine. Let's take a look at the error. Incompatible voids of function pointer types passing void star to parameter of type void star. So now I'm passing. So this is where my understanding of C is going to let me down, isn't it? Incompatible function type pointer types. So I'm passing a void. I mean, you don't do like this, do you? No. Oh. I might have to cheat here and look up what it was saying. What the article was saying. At least we got this right. The thread. Here we have a function. Yeah, I mean, I think we can just make it take no arguments. I think. Although was I thinking you need to do that because of how Pthread create. It wants you to do a start routine. Yeah, let's just check the article. See if I can find it. It wasn't this. Well, here's an example. Oh. It needs to return a void star. That was all it was. Okay. So that was got from the fact. Where was that from? Do you know that because of this, maybe? Needs to be a void star. And this thing about the arguments. Does this not matter anymore? No, it does matter. Interesting. So let's just try something. A type. So it couldn't take a type, could it? No. Interesting. So I think basically, wow, Cinderella, dude, how's it going? It's been a while, hasn't it? So yeah, it seems like this function needs to take a void star. It needs to return a void star. So yeah, I think this value here is going well. Oh, I'm glad to hear it's going well. How have you been this past year? Well, the past 2 years, I guess, isn't it? Have we? I don't know if our paths have crossed since the pandemic began. I don't know if you can tell, actually, by the way, that I'm in a different location from where I usually was. I mean, it looks very similar to how it used to look, so I probably can't tell that I've moved. But yeah, if you wanted to pass an A type to this, I think this is the thing that you'd use to pass it. And then in here, I suppose you just have to cast the arguments to the actual type you want, I think. But for now, let's just do, let's kick off a couple of threads and just see if we can get a bit of an understanding as to what is happening. So Not sure. Bookshelves, yeah, dude, yeah. That's a good memory, actually. Yeah. So I think, yeah, the bookshelf used to be. It used to be to my left. Yeah. So at the moment, yeah, I've got like a little I'll just move the camera around to show you a bit more. There's I don't know if you can see that at all. It's like Christmas cards on a CD rack. So that CD rack actually is the top thing which you can see. I made that in woodwork like 20 odd years ago. And the bookshelf, as you can sort of see, I'll just turn it around. That bookshelf is kind of like over there. And it's also stacked up. There's like two. There's like one above the other. I don't know if you can sort of see that. It's kind of like quite tall. But yeah, that's what's going on. So yeah. So you finished college. You started to play it out at the point in your life. Oh man! Congratulations on finishing college. Yeah, I do as well. So I love a filled one, but sadly it's not actually sorted. It's not in alphabetical order, and it's not even like series aren't even together. So I've got the Lord of the Rings in there, and for some reason it's just spread out over different shelves. So yeah, it's a bit of it's one of those things. I need to kind of like just get on and do it, but I just haven't actually gone for it. So yeah, college in the US, that is like, that's university level, isn't it? So does that mean that you've like got a degree on the to-do list? Yeah, exactly. Because I didn't actually finish college here. College here is like, I think it's 17 to 19 or 16 to 18. So I did my first year, and because I was like not really applying myself, I got sick of it, and I started the second year but didn't actually complete it. So yeah, I dropped out of college, like UK's college, and then I later went and did a degree with the Open University. So yeah. So university. You did a bachelor's, so 4 years. Cool. At 18 you finished high school. Right, yeah. Interesting. Yeah. So we do, at 16 we have like, we sort of finished high school like year 11 or fifth year, depending on what you want to call it, at 16. And then you've got like sixth form, which you could do at your high school. So I could have done that at my high school. You could stay on to do sixth form there, but I actually went to a separate college to do that, or to start it at least. Yeah. So was that in like computer science? I can't even remember what it was you were even doing. Yeah. Here's that. It's cool. Nice. Okay, let's just see about something here. Let's make them do something for a start. ++8. There we go. I've been a bit tardy actually with programming, so yeah, I might be coming out with all sorts of garbage stuff that you just wouldn't usually do. But yeah, printf. Oh yeah, another thing I was thinking of doing actually was printing out the function name. Now let me just see if you can do that just directly in here. I don't think you can. Well, yeah, if we do that the right way around, it might do. Yeah, you can, cool. Ah, right, it's just the whole course. Right, interesting. Well, maybe we have to suss out what method I'm doing there. Because I won't know what it is. Yeah, so let's just run this, and I'm suspecting that we might not even see any printing actually, depending on how quickly the parent thread goes. So here we go, we've got a write memory access already. So, yeah, of course, so sorry, we don't want to do this for a start. So yeah, let's try that again. Interesting. Peter's a perfect physical computer, yeah. Can't really use anything else. Oh yeah, what was the error? It can't be empty. Is that just a Clang thing, I wonder? 'Cause I feel like I have done that before. No. Okay, fine. Yeah, I will fill it out. Yeah. So yeah, as I say, it's not printing anything out because parent thread is finishing too early, so let's just make it sleep to give it time, and then I'll do what we actually need to do. Ah, I see, PHP. Cool. Yeah, so here we go. We've got thread A stuff happening, and then thread B stuff happens after, which is kind of interesting, I guess. I suppose actually another thing you can do actually is make it sleep after each thing, isn't it? And this probably won't have enough time to actually do everything. Yeah, there we go. So that would be what I'd expect to happen. Yeah, cool. And also, because there's only 8 things. Oh, right, so this should just complete, shouldn't it? Give or take, you know, 1 iteration. Yeah, that seems to be bang on. Okay, cool. So what we actually need to do, I believe, is to join so you just pass the thread and the return value, which you can do as null. So we want to join thread A. We could just join it straight after creating it, I guess. And return value. Alright, we're in business. Now, yeah, that's interesting. We've got thread A stuff happening, and then thread B. That's interesting. So that suggests, oh, I know why that's happening. Pthread join basically sort of essentially blocks, if you like, until thread A returns. Like, that's the whole point of it almost. So it's only when thread A returns that this will actually be able to proceed. So I should really do that. It stops on join, yeah. Oh, that's interesting, look at that. Thread B actually went first that time. Is that a consistent pattern. That probably will be consistent, won't it? Because they're both waiting for a full second. I wonder if that's just because we join them in that order, or whether that's just pure fluke. Ah, there we go. That was interesting. Thread B happened twice in a row. Yeah, that's cool. Right. So I think that is the sum total of what I remember from that article. So dude, what are you going to do with your degree, do you think? Because it's computer engineering, right? Let's just double check that actually. Computer science. Computer science, yeah. So what sort of stuff are you fancying? You can do this, can't you? No. Never mind. You want games? Yeah. That is one thing that I haven't actually started to do yet. Ah, you've got JI. Nice one. So are you in the beta then? Or is it... It's not open... it's not fully released, is it? To be honest, I haven't actually... Yeah, you're in the beta. Nice one. Yeah, I haven't really been following John's streams that at all closely. Close now, yeah. Yeah, I just sort of pop his stream up every so often, just briefly. Like last night he was streaming, so I popped it on for like 5 minutes or something. I've got no idea what he was actually doing. I think I was just sort of procrastinating before actually going to bed. Yeah, let me just take a look actually how long this file is. It's 1200 words, 1200 lines. So yeah, I think one thing, the next thing I could do with doing is actually passing some arguments to it, isn't it? You know, so we've got this void star args, and I think that's what it has to be, isn't it? But you can't just pass a pointer to an int. It's got to be a pointer to void star, I think. And that would be this. So let's... Yeah, let's just make some structures that each of them might take. I mean, it's possible that I wouldn't actually end up using this sort of stuff, but I think it's worthwhile learning it. So we've got an A type and a B type. So yeah, so we could do like a starting number and a count, can't we? I'm just sort of thinking that what's something that the loop could work on. And this is going to cast the args. So this needs to be data count, and this would be like data starter plus I. And args needs to actually exist, so it can't be null. Yeah, it's kind of interesting, returning a void star. Let's check. Yeah, it does have to be a void star that it's returning as well. You know, it's not like you could return like 1 or 0, basically. Yeah, I wonder what I would use. I wonder what I would return, actually. Let's just copy this down here. And this should be B type. Yeah, I know they're basically the same thing, by the way. So it's a waste of time, kind of like having 2 separate things. But you know, at least it kind of like gets us going. It's A type, and let's just say it starts at 8 and it goes for 12 runs. I want this to start at 44. So this needs to be appointed to that. It compiled first time. So let's see what it does. Yeah, I mean that seems fine to me. So B starts at 4. Looks good. Okay. So this null thing here. Let's just check this. So this is the attributes T. It's initialized using Pthread attribute init. Let's take a look at that. Pthread attribute init. Update. Pointed by attribute default attribute after this called individual attribute. List under C also, okay. Attributes, subjects, attributes, independent behavior. Okay, dokie. Interesting. Joinable. Displays and attributes. So, here is what we can use. Set affinity, NP. You don't think you ever used it? Okay. Well, that's a good hint for me. That one probably won't need to bother. set attached state, set card size, set inherited scheduler, set shed param, set shed policy, set scope, set sigmask np, set stack address, set stack size, Pthread create. Yeah, then these are different. Oh well, no, there's get attribute np, and then set attribute default np pthreads. Interesting. I mean, I guess it could be interesting to take a look at what we've got. How does anything except for mutexes, conditional variables, create thread join? This is all new territory. Cool. Yeah, I mean, let me make a note in mutexes actually, because that is definitely something I need to do. And you say conditional variables as well. So this would need to be a pthread. T. And then we would also need to destroy, isn't it? Was it this? Was it a trip? Think of you're learning how you want to do the atomic stuff, semaphores. Interesting. I'll make note of them as well. Produce consumer. And then you say the atomic stuff. Let me organise my notes. Get to the yeah, mutexes were definitely on my radar for something to do. So atomic means when it's something's happened at the same time, isn't it? Is that right? Like in one movement, a thing happens, or multiple things happen. Because I sort of have in Cinderella the database writing. The way that I do that is that I write the actual database to a separate file. So rather than writing like pieces of data one after the other to the actual file, I think what I do is I write pieces of data one after the other to like a temporary file, and then only if all of that completes, I then like do this atomic operation of swapping in the the temporary one for the real one. Semaphores are just mutexes and conditional variables. Ah. Semaphores are just conditional. So I misunderstand that. Conditional variables are good for produce consumer. Which is conditional or semaphores. Okay. We'll get to this stuff. Yeah. Let's make a... Well, I want to keep the word semaphores in it as well, though, I guess. Let's keep it like that. It's fungible. Breakfast sounds good, actually. I've already had breakfast because it's 5 to 4 here. But I'm getting a bit hungry, actually. Not going to be going anywhere soon, though. Yeah, okay, so let's see. So this is the attributes, isn't it? We can pass attrib here. Can't I? Yeah. And I think it was saying that when you call this, that initializes it as the default. So, and similarly, this, you know, when you pass a null to here, then Pthread create will automatically use the defaults, I think is what you're saying. So I think we should get the same behavior. Fungible, oh god. Yeah. Yeah, so we're getting the same stuff happening here. Set affinity, set detached state, set guard. Ah, wasn't set attachable something? Or set joinable? Yeah, let's have a look at set detached state. Don't forget to do. Oh yeah, cheers. Oops. Oh. Ah, yeah, right. So we've got set and get. The following value specified in detached state. Create detached. Threads created will be created in a joinable state. Yeah, that's interesting because this is kind of like what I was imagining. So if you say that it isn't joinable, I'm going to try and do this. So here's our attribute, set detached state. I'm going to try and set it as this. So what's happening here also? Yeah, so this thing is going to be doing, A needs to continue after B's finished its stuff because it's doing fewer iterations. Yeah, so what I'm suggesting here is that because it's detached and it's not apparently not joinable, that this won't do anything, and that when B stuff does its final thing here, I think that should be the final thing that we see. Let's see if that's what happens. Yeah. Oh, by the way, I've just got to mention. Can I do this? No, of course I can't. Why not? Well. Is it capitalised? It's not capitalised, but whatever. Awesome track that is. Let me let me link you to it. I'm going to tease something here. I'm actually currently learning how to play this on the guitar. The only bad thing about it is it's too short. Well, yeah, until I pull up the web browser, isn't it? So what is happening here? I think I need to do, this is where it gets a bit awkward actually. I need to do this. And then this. Yeah, I think that's just because of Firefox. Actually, I think if I was to well, it doesn't matter, who cares? Because if I was using Qt Browser here, I could copy it to either of the clipboards, but I think Firefox only puts it into the secondary clipboard, and I can't paste out of the secondary into here. There is, yeah. Yeah, I do have that actually. Is it W3C or W3M? Might be another one. I should just see how this might go. So yeah, I wanted to send you Rude Buster. So how do you do that exactly? Probably in here, is it? Copy. Yeah, it's going to be in here somewhere, isn't it? I mean, another option actually will be to go to the thing. Oh no, it's not showing the. Actually, yes, this could be another option. Right, and then you use Tmux to copy it, and then you write that. Yeah, that's another option. Yeah, so there we go. W3M. Yeah. Yeah, I've got to be honest, I don't really use these at all. Yes, I do want to exit it. Yeah, please. Yeah, anyway. So that was nice. It did exactly what I was expecting it to do. I'm just trying to think of like why you'd want to do that. I mean, I suppose it, you know, if you're going to be doing something that doesn't, that nothing else depends on, and you don't care if it completes its work or not. So yeah, also because of this Pthread, this is like an enum sort of thing. Let me just see. Let me have a little look at that example, just a second. Just want to see if there's like, if it can get a string. Yeah, no, it can't really. It's just sort of, you need to write it out yourself. Oh, they're actually, you actually need to define your own, well, I suppose, yeah, your own function. So when this, yeah, when this starts a thread, you can see it's like a void star and it takes a void. So yeah, upon starting a thread, yeah, this populates here. I mean, I suppose, because there aren't that many attributes, are there? There's only like 8 attributes or something. Or 8 or 9, is it? 8, I think. So you've got detached state, scope. It's really cool you just have a look at the man pages for each of these things. So let's just do that. You know, because this one kind of worked as I expected it to. So affinity, it sets a CPU affinity mask attribute to the thread attributes object referred to by attribute to the values specified in CPU set. This attribute determines the CPU affinity mask of a thread created using the thread attributes object attribute. The get one returns the CPU affinity mask. For more detail on CPU affinity masks, see this. Yeah, I've actually got no idea what this is all about, actually. I've never heard of affinity. A thread CPU affinity mask determines the set of CPUs on which it is eligible to... Oh, okay, interesting. And what's for the system? Performance benefits. For example, by dedicating one CPU to a particular thread. Ah. Maximum execution speed for that thread. Restricting the thread to run on a single CPU also avoids the performance cost caused by the validation that occurs when a thread ceases to be. Ah. A CPU affinity mask is represented by the CPU set T structure. CPU set pointed by mask. A set of masks, macros from measuring CPU to sets described in CPU set. His ID is PID to the value specified by the mask. The set of CPUs on which the thread will actually run is the intersection of the set specified in the mask arguments. The various ways of a common setting on lows dose where the task manager allows you to set which so this computer here has got 4 cores. So the glass plate. Yeah, it's banned actually. Yeah, that will have been banned since the very beginning, won't it? Lose dose is a good way of doing it though. Oh, lose. Ah, yeah, got it, got you. Lose down. Lose dows. I like it. So yeah, on what was the sense you ask your benefits? I'm gonna just try getting this actually. I think. I assume the CPU set size for me should equal to 4, I guess. Because basically, you know, if you don't set an affinity, I assume that it would default to allowing it to operate on all things. Sorry, it was the other one too. So yeah, we got our attributes. CPU set size. Oh, sorry, it's just the data point to my mask. Oh, so that's all it is. Well, this seems a bit more straightforward than I was sort of thinking it might end up being. So if you just initialize this to whatever. PIDT, I don't know, do I? It's going to be the process ID of the thread, isn't it? I think. So I'll need to get that somehow. So yeah, when I create the thread, do I get an ID? Yes, I get the ID here. I assume that's what the return value is at least. Oh. Just see what this can contain. Well, actually, I can look in the header content. Yeah, it's always awkward to me that I know it's just tough to find the type, sadly. You got to take one notes, you can read. Nice one. Well, the font is also a bit bigger than it used to be. I'll tell you why as well, and I'll tell you and show you. So, the other day I was listening to David Bowie's Black Star album, and you can see that it uses an actual star. Yeah, it's not a payable. It uses an actual black star as the thing, but I'll just show you. For some really awkward reason, is that. If you're on 12, it just displays a box like this. Like it just can't do it. Okay. But if you go up to 13 it can. But the trouble when you go up to 13 then is that the font is a bit like wider proportionally than it was on the 12. So I just kind of found that here you get the actual font, the actual glyph coming through. But I just found that 16 was like the closest to in proportion. And another thing actually also is that I want the bottom of the I want the terminal to be the height of the full screen. So I think I'm still on 12 here, aren't I? Now if I go over here, this is as high as it'll go. Yeah, this is as tall as it'll go. But there's like space below the bottom here. So it was only at 12 and 16 that you actually get the full height. And it's only at 16 that you get the actual glyph coming through. So yeah, that's the reason why it's actually bigger than it used to be. Yeah. It seems alright for now though, for me. Yeah, tell me about it. Here we go, this looks promising. Pthread types. So a Pthread cheat, an unsigned long int. Ah. So is that just the ID then? You think, I'm telling you, integrate the shard font, it looks good at those. Yeah. Yeah, that's what this is. Yeah, I mean, I've got multiple things, multiple fonts actually in that X resources. All these to kind of accommodate stuff that Consolata is missing. I can't bring to mind what those things actually are, but I think one of the things actually is the character that I've got that kind of splits yeah, this character here, like that isn't in Consolata. You can see I was looking at that black star. Yeah, this is from this font, Han Nom A. I don't know if that's coming through. Yeah. The P, this. Let's have a look at this. Oh, I think I might have a Firefox already open. Ah, very kind of bitmappy, isn't it? Yeah, I do kind of like it though, because I like the kind of proportions that it's in. I might like that for my console. 2 terminus 16 is what I've got in the console currently, whatever that is. I mean, it's something that I set specifically, so I evidently chose it. Yeah. Yeah, cool. Okay, let's try and do a bit more thread thing. Yeah, there's PID underscore T. Let me just have a look at what PID underscore T is. I mean, it'll probably just be an int or something. Yeah. Hang on, I wonder if you need to actually get the ID. It's like a get ID or something. Or is it in the attributes, I wonder? Oh, that's interesting. Thread ID. Hang on. It's a pthread join. You just pass the thread. So maybe that is actually sufficient. I'll tell you what I'm talking about in a second. Why did I need that? That was for this, wasn't it? Yeah, the PID. I can't do get, fortunately. So yeah, it takes the attributes, the size of a CPU set, and it takes a CPU set to store the stuff, right? Let's just try this. So it was the thread A. I think it was a point to it, wasn't it? A size of a CPU set T, and then a CPU set. I'm going to have to like this so we can set it. Now these tend never to work for me actually. Underscore GNU underscore source. Yeah. I mean, what I invariably find myself having to do here, I wanted to call get thread get affinity np, right? So what I invariably find myself having to do is what was it called again? Get affinity np. Right. So this is where this function is. And it's within an if-def use GNU. Right. So now I want to localT. Yeah, but do you see what I mean though? At least we've managed to get this available to us in a way that wasn't documented. You know, like use GNU isn't here. So now we just need to solve the other problem. Which is the unknown locale, unknown type, localT. Trying to think what that would be. Is there a locale.h? Well, there kind of is. And this one's this, I think. So now we need clock ID T. Is that going to be in time T? Sorry, time H rather. IO.H. Sorry, no, it's clock T into. It's just types.H. Yeah, same here, man. Alright, well I think we seem to at least be passing the test. So this wanted, oh sorry, it's the attributes it needs. Right, but actually finally managed to get it to build. So yeah, like all I wanted was this function here, wasn't it? Sorry. This function here, and it's saying that you need to define GNU source. It also says C feature test macro is 7. But in order to like get all of that in, I needed to include these, I think, at least it is. Yeah, so localT is not in systypes. Yeah, so, you know, just get that sort of situation. Anyway, get affinity. I think what I'm going to do here actually just build it and just step over that line, I think. So it starts out with garbage in. We step over that to get the affinity, and now it contains that 16 times. Okay, I might need to see how to interpret that. CPU set. CPU affinity mask. Let me just check that I've initialized the attributes, yeah. Check that this is doing what I'd expect as well, actually. Yeah. So yeah, let's check with this. Aha. For description system markers that we use to manipulate and inspect CPU sets, the CPU set. Okay. I have to do that over here. The reference is such a CPU sets used by shared set for oh, of course, yeah, I suppose it's a bit mask, isn't it? So, you know, that value could just be, you know, a number of bits being set. That clears the set as it contains no CPUs. Add a CPU. Return the number of CPUs in set. That's interesting. Let's have a look at that. CPU underscore count, all caps. You pass the set to it. So it reckons I've got a CPU count of 1024. Return the number of CPUs in set. Huh. Okay, so I think I'm probably not understanding exactly what that's trying to tell me there. Let me just make a note of this. So we're talking about affinity, basically. It's basically just trying to nail down my understanding of it. Where did I find that, all that information? There was a bunch of information about affinity, wasn't there? Was it under create? It was under there, wasn't it? Shared set affinity. Yeah. Dedicating one CPU to a particular thread. Yeah, let's make a note of that. Because, I mean, although I don't really have an immediate use for this, it kind of sounds like it probably would be interesting and useful for me. So yeah, we've got set affinity. Tell you what, let's just grab all of these. Set affinity set is actually a guard size. Yeah, okay, so we've got affinity, we've got detached state. So I don't need to be looking at this for attributes. That'd be default of all, I think. Ah, right, okay. So you're changing what the defaults would be, I think. Yeah, so let's leave that out for now. Yeah, but these things could be worth doing. The detached state we've done. Let's bullet point these guys. Oops. Yeah, so we've done the detached states. And this set affinity, we're kind of still looking at. So yeah, I need to look at the guard size, the inherits scheduler, the shed param, shed policy, the scope, sigmask, the stack address, and the stack size. Gosh. Have a quick look at this. sets the stack address and stack size by a thread. Yeah, I mean, what was kind of going through my mind was, I wonder if it'd be worth having multiple threads sharing the same stack, but it probably wouldn't at all. Yeah, because all you want your stack for is to, keep track of your local variables and your function kind of calls, isn't it? Which is going to be thread specific. So yeah, let's just call this attributes to look into. And I think, I'll tell you what, I might call it here, actually. I'll just check how long I've been going. Well, I've only been going an hour and a half. Yeah, I mean, I could do with going to the shop, you see. Or I could at least do with going to the toilet. Tell you what, let me just put the stream on pause just a sec. I'll just use a loo and and then just quickly scan through these, I think. So yeah, I'll just be back in a sec. Zillow's goes looking into breakfast. What did I say it was? An hour and 36. I mean, I suppose now that I've kind of like done a break, I suppose I might as well just do a bit more. Yeah, I'll probably just do another 15 minutes, I think. Finish at about 5-ish, and then I'll pop to the shops. So yeah, we've looked at set affinity. We're going to continue to look into that a bit more, sort of mull it over, I guess, thinking about what we can make of it. Set detached date we've used, and I think we've understood what's going on with that. Yeah, there's only the two options to set. There's the two values, and the by default set to be joinable. So that was a piece of cake. Set the guard size. So the Pthread attribute set guard size function sets the guard size attribute to the thread attributes object, referred to by attribute to the value specified in guard size. If guard size is greater than 0, then for each new thread created using attribute, the system allocates an additional region of elite guard side bytes at the end of the thread stack to act as the guard area for the stack, but see logs. If guard size is 0, then new threads created with attribute will not have a guard area. The default guard size is the same as the system page size. If the stack address attribute has been set in attribute using either of these, meaning that the caller is allocated in the thread stack, then the guard size attribute is ignored, i.e. no guard area is created by the system. It is the application's responsibility to handle stack overflow, perhaps by using mprotect, to manually define a guard area at the end of the stack that it has allocated. Okay. So we automatically get a page size. We automatically get a system page size. Yeah, bugs is the thing you were saying, wasn't it? As a glibc 2.8, the NPTL threading implementation includes the guard area within the stack size allocation, rather than allocating extra space at the end of the stack, as POSIX.1 requires. Okay. The obsolete Linux threads implementation did the right thing, allocating extra space at the end of the stack for the guard area. Okay, I mean, I think by the sounds of it, this is all just going to get taken care of for me. So yeah, I don't think I need to necessarily bother about this. And also, these guys. Can I just replace them with a space? Because that way, if I go there, that will work. So, did I actually tick that? Yeah, I did. So, the inherit shed. The Pthread attribute function sets the inherit scheduler attribute to the thread attributes object referred to by attribute to the value specified in inherit shed. So, options are inherit and explicit. It determines whether a thread created using the thread attributes object attribute will inherit its scheduling attributes from the calling thread, or whether it will take them from attribute. The following scheduling attributes are affected by the inherited policy. Yeah, I'm going to have to look at this scheduling policy also. Scheduling priority. The following through. Yeah, so it's either inherits. Or they're explicit. So yeah, I assume it's inherit, and yeah, the default setting of the inherit scheduler and the new inherit directory is Pthread inherit shed. Okay, so this is to do with the shed policy. Shed param and the set scope. These guys. So the policy, the param and the scope. So look at this. This function sets the scheduling parameter attribute to the thread attributes object referred to by attribute to the values especially the buffer pointed to by param. These attributes determine the scheduling parameters of the thread created using the thread attributes object. The parameters are maintained in the following structure. Shared priority. Only one scheduling parameter is supported. Due to the permitted ranges for scheduling parameters in each scheduling policy, see shed. So yeah, there's further reading for this, which is the shed man page. Shed 7. Double check that it will be that. Yeah, I was thinking like niceness was part of it. What was that saying actually? Sheds. Well, it's param, isn't it? I think. Yeah, so I don't think I will read this just at the moment. I think I'm just going to go through the the remainder of these guys. We have done this, and this we've saying we've got more to read. The policy. First in, first out, round robin, and other. Sets the scheduling policy attribute to the thread attributes order to the values. This order is the scheduling policy of a thread created using the thread attributes objects. Yeah. That's interesting. I think this is potentially important. So it's, yeah, set scheduler. Sporadic. Yeah, so I think I'm going to leave these as more to read. Ah, there we go. Atomicity. Yeah, so this is More to read. Set the scope. Now, was this one part of, you know, the set inherit shared? Was that part of it? Yeah. Set scope. So this was also a thing that could be inherited. The Pthread attribute set scope function sets the contention scope attribute of the thread attributes object referred to by attribute of the value specified. In scope, this contention scope attribute defines a set of threads against which a thread competes for resources such as the CPU. Process specifies two possible values for scope. System and process. The thread competes for resources with all other threads in all processes on systems that are in the same scheduling allocation domain. A group of one or more process cells. Pthread scope system threads are scheduled relative to one another according to their scheduling policy and priority. It competes for resources with all other threads in all processes on the system that are in the same scheduling allocation domain. Okay. And if it just process, the thread competes for resources with all other threads in the same process that were also created with the Pthread scope process contingent scope. The Pthread scope process threads are scheduled relative to other threads in the process according to their scheduling policy and priority. Process 1 leaves it unspecified how these threads contend with other threads and other processes on the system, or with other threads in the same process that were created with the Pthread scope system contention scope. Process 1 requires that an implementation supports at least one of these contention scopes. So then it supports the scope system. Oh, but not scope process. Okay, so that takes that decision out of my hands. On systems that support multiple contention scopes, then, in order for the parameter setting made by Pthread attribute set scope to have effect when calling Pthread create, the caller must use Pthread set attribute inherit to explicit. Yeah. The Pthread attribute gets scope. Yeah. Okay, so I only have scope system, isn't it? Fine. So that means that we've read this, and we've got nothing, no further questions, Your Honour. Set sig mask. It sets the signal mask attribute of the thread. Hang on, is a signal stuff like sig kill and sig whatever it is? Oops, what was it? You know, these things, sig term. I wonder if that's what they are. It returns a signal mask attribute the thread attributes object referred to by in the buffer pointed to currently on set this function with a special value Pthread attribute no signal mask and appears its result. The signal mask attribute is the signal mask that will be assigned to a thread created using the thread attributes object atch. If this attribute is not set, then a thread created using attribute will inherit a copy of the creating thread's signal mask. For more details on signal masks, see sig proc mask. That's what we'll probably need. For a description of a set of macros that can be used to manipulate and display signal sets, see sig set sig triceratops. Did it say what page that was? Ops 3. Yeah, so I think that's potentially further reading there, but it doesn't sound, on the face of it, to be too pressing for me to get into that. Set the stack. Yay, it's Varus. That's alright. I don't know if you spotted the message that I pinged over earlier. Does my thing? Yeah, see something with HMNIC certificates. Yeah, obviously certs. Yeah, so yeah, that's fine. Yeah, I won't bombard you with it. I will just say that the only reason I think it's not me is that well, so this is the server, right? This is where the actual WeChat is connecting to. So this instance of WeChat is connecting to HMNIRC. Whereas this instance here is my local one. Sorry, where are we? Yeah, this one down here is my local one connecting to the one on the server. So this is having trouble connecting. But in addition to that, this one here on the server is having trouble connecting. And all it seems to be saying is peer certificate is not trusted. TLS handshake failed. Error in the certificate. So yeah, this is saying this, whereas in Libera, it kind of says peer certificate is trusted. So you know what I mean? It's kind of like this seems to be able to connect okay, and similarly like my local one can't connect to Libera. So I do have a problem with my actual certificate on Cliff Dweller. So that's not trusted, but it can get through, no problem. So how would I do this exactly? Oh, I'll tell you what. Actually, this is also pretty out of date. So it probably is actually just my certificates that are out of date, isn't it? Yeah, I might have to look at that later. It's possible that I won't be able to actually update it even, because I think it is actually out of. It's no longer supported. It's beyond its life, or whatever. Yeah. Okay. But yeah, CA certificates. Yeah, I'll try and look into that. By the way, I'll just show you what I've got for the program. I'm currently just looking through the attributes that you can set for your threads after having done a little bit of stuff here. So I've got a couple of threads. I've sussed out how to, pass. I've sussed out how to create the threads, how to pass parameter, like function arguments, function parameters, whatever you call them, to the thing, and also like to, obviously you've got to cast it. You've got to cast it to the actual type you need inside the function. So yeah, I've got these couple of things. The CPU count, I don't fully understand, I need to continue to read about this. But yeah, I'm kicking off 2 threads, A and B, and this data thing just says, you can see that it's printing out like a count. Well, the data is going to be just, well, I'll just show you. It's the starting int and the count. So for A, I've got it starting at 8. I think it does 12, yeah. 8 and 12. Whereas B starts at 4 and does 4 iterations. So yeah, that's what it should do. So as you can sort of imagine, 8 should actually, so thread A should start at 8 and do 12 iterations, but we don't actually get all the way to the end of its run because we've set this particular attribute, Pthread create detached. So I think if we, I think it's joinable. Nope. What doesn't go to an TMP? Yeah, I think it's joinable. If we just set that, and then I believe it should actually finish its run. And sure enough, it does. Yeah, so I think that's the sum total of what I've actually learned how to do. And then obviously joining the threads, because if you don't join them, then it'll just exit. Oh yeah, I haven't actually done a return. I suppose I could get them to set a return value. Yeah, but yeah, what I'm sort of doing here is just I'm just looking through the attributes just to see what you can set. I think I might actually just So yeah, all it means is that the join thing won't work. I mean, I haven't really thought of what the point would be in it, but essentially setting detached is essentially the same as like not calling pthread join on that thread essentially, because when you try to do it, it will just, well, I suppose it just not allow you to join it. Yeah, well, I was kind of racking my brains as to why you would want to do it, and I was just sort of thinking, well, could it be if you were to have a thread running that's like no other thread, like a parent thread, doesn't depend on the work that your created thread is doing, and like you just don't care if it finishes doing its work or not. But yeah, as for like a practical use for that, I just don't know. Yeah. But anyway, I think we looked through set sigmask, So these things here are sort of still to study basically. This stuff to this scheduling. And these things that are ticked off are ones that are done with basically. So for example, this set scope one is to do with the scope. It's to do with the resources that the thread contends with. So on Linux we have no option other than to have the threads contending with all the other threads on all the other processes that are running in the system. Whereas on another operating system you might be able to sort of say that the thread only contends with threads on the same system. I think I've remembered that right. Yeah. It's a pre-thread scope system. Oh, sorry, yeah. In the same scheduling allocation domain is what I didn't include. Yeah, but we don't have a choice. It says on here, it says somewhere. Yeah, Linux supports Pthread scope system, but not Pthread scope process. So, you know, there's no choice for me. So, I've just ticked that off. That's something that I've studied enough of. Yeah, and I think I was looking at set stack, wasn't I? So let's just have another quick look at this. It says the stack address and the stack size. Yeah, I mean that's kind of interesting because we've got these separate functions. So maybe set stack does both. That's going to be what it is, isn't it? Yeah. Yeah. So again, I haven't really thought of a use for this. I think this is probably going to be ticked off, I reckon. The fact place, the must install a threads stack is placed in a particular location. Yeah, for most applications this is not necessary. And these functions will be avoided. Yeah, that's what I'm kind of intending. Use this if an application simply requires a stack size other than the default. Yeah. Yeah, I'm going to consider this ticked off. And then I assume that this is just going to be the same information except half of it either obsolete, so fair enough. So that's that. I assume that's the one that's obsolete. Ah, that's the point, yeah, it's not actually obsolete. It says that I got rid of. Yeah, so they're gonna get to default anyway, so I don't think I need to necessarily bother. So the things I'm interested in is the affinity, the shed param, the shed policy, and the set sig mask. I think the sig mask was one I was thinking I probably won't need to bother with. The shed param and the shed policy. So that's to do with whether it's first in, first out, round robin, or sporadic, I think was the other one, wasn't it? Yeah, shed sporadic. And while I was reading through this, I kind of thought that it sounds like you would be setting this kind of thing on multiple threads, and they'd all be kind of like operating relative to each other. Because if you look, yeah, so this function is not atomic with respect to other threads in the process. But yeah, that's another one that's more, to read. Need to continue reading that. The shared param, meanwhile, it's just a single value, wasn't it? So yeah, I think I need to. That's another one I just want to read a bit further on. The affinity though is sort of saying that's to do with like particular CPUs doing the work, threads only being only having particular CPUs doing the work. So this kind of sounds like it's potentially useful. Was it this one that was a bit more helpful, actually? Yeah, so the affinity mask determines the set of CPUs on which it is eligible to run. So that, yeah, this paragraph is just talking about, it can be used to enjoy maximum execution speed, basically. I think what was at here is trying to get the thread ID. It's trying to find the thread ID or the process ID. I think probably the thread ID actually. Although did I get that? Did I get that? Shared get affinity. Yeah, so I didn't quite call this, but I did call this. And from the affinity, I determined that the CPU count was apparently 1024. Now, when I was first calling this, I thought that I'd be coming out with a CPU count of 4, or possibly 8, because this chip has got 4 cores, each of which is like I think it's hyper-threaded. I think for both scheduling and affinity, you can just ignore them and let the OS decide. If anybody usually wants a maximum volume by 600, yeah, dude, yeah. Yeah, that's exactly my understanding as well. So yeah, for the scheduling, yeah, that can like round robin and first in first out thing, and sporadic. I haven't quite got my head around what the utility of it would be, so I'm going to keep it as an open question for now. But yeah, the affinity, I think I can sort of roughly see what its utility might kind of be. It'd just be a case of trying to put it into practice, yeah. So yeah, those are things to do. Now I'm going to actually start to wrap up here, dude. Yeah, I've been over 2 hours, and I need to go to the shops, you see. But before I do, I'll just recap why I'm doing this threading in the first place. So yeah, as we know, I've got this program here, Cinderella, which is the thing that ingests HTML indexing files and produces stuffs some of the information into a database, and some of the information it doesn't put into the database, and it produces HTML files. For the last few months, I've been making a reference manager basically, and that thing is here. just call it ref store for now, and it basically stores reference information. And these are all the instructions that it supports. And in addition to that, I've got a client that can sort of get the information from that store. And it can also you can also create relationships between things. And the way that I'm doing it, by the way, is inspired by Book Brains. Can I just get that up? I think it's Book Brains. Yeah, it is Book Brains. So it's the way that this does it. Yeah, so this is basically the page that I kind of use to do it, and it's essentially, yeah, it's all based on relationships between things. So like, rather than having like a book that has a title, an author, a publishing date, and publisher and illustrator, all like in the same bit of information, what you have is we have different things. You've got an author, work, an edition group, and a publisher, and you sort of say that a work is a thing that is written. So, for example, I'll just show you in what I've got here, and also I'll just, well, is this going to work? Yeah, it doesn't. It's a bit, but it's not completely done actually. But if I just open it like this, then you'll be able to see it a bit bigger. So I've got authors, editions, edition groups, publishers, and works. So you can see here that we've got the Well of Loneliness. You can see that it was written by Radcliffe Hall, and it's contained in the Well of Loneliness. And this Well of Loneliness is the edition, this thing here. So you can say that this contains the Well of Loneliness, but the edition doesn't actually have a written by thing, because that's only on the work. You can see that this particular edition is contained in this, and this is an edition group. So this edition group is containing that. And you can see that this is published by Wordsworth Editions Limited. And then obviously separately, then you've got your publishers. You've got publisher, Wordsworth Editions here, published The Well of Loneliness. You know, so you basically, rather than having like a single thing that is, there's got multiple bits to it, it's like you've got multiple bits that are kind of like related to each other. And kind of the reason I kind of did it this way is that it allows the entries to be a bit more kind of like tractably sized, if that makes sense. You can kind of like more readily predict how big every thing needs to be, like how much space you need to have available for it in the database. So yeah, I mean, it's completely broken, but that was kind of like the advantage of it for me. It's probably not finished actually, but anyway, the back to this actual story. There's a bit of original with Funky. Yeah, I haven't actually heard of Funky Between Tables, actually, but yeah, I think it's probably a relational database. Yeah. So the threading thing, I was sort of thinking that the way that the program should be is like this, you know, separate programs. So you've got your Cinderella over here, you've got your reference store there, and you've got various clients kind of like plugging into the reference store. I'll also show, by the way, that I've got this hard-coded client. Yeah, so this is like a programmatic client, basically. And this is the only one that can actually add things to the database. Like this client can't actually add any new things. But yeah, I can leave that showing up actually. I was sort of thinking it'd be reasonable to have a separate reference store. Yeah, like a sort of like a reasonable example of a sort of, what do we call it? Yeah, a setup would be like having the reference store running separately, and having like one reference store and having multiple instances of Cinderella able to get information from the reference store. So that was why I was sort of thinking why to have it as a separate program. But then I just thought that for like, installing a new, it's like somebody's coming along and they're wanting to publish this stuff. They're going to need Cinderella to publish it, and then if Cinderella itself is going to be like using a reference store, they're going to also have to be installing a reference store. But the thing is though, it's really common to actually have references. So I just thought, wouldn't it just be easier to just have them all in the same thing, basically? So they're all in the same program. Somebody just needs to install one thing. The rest of the entities and also, yeah, exactly, yeah. Yeah, so the entities are only like related to each other. But when something like Cinderella then comes along, and say like you've cited one of the reference IDs in your indexing files. So like the way that I currently do it, right, is I probably, yeah, so I did a reference here. So rather than writing this, I'll be writing something like ref ID is equal to something. So rather than having all that information, you just have like just the ID, and then Cinderella would be able to call into the reference store and pull that reference out. And the thing is, it needs to actually know like how to actually present it. Like sadly, Cinderella needs like the author, it needs the title, it needs the publisher, it needs all those bits of information. So I might actually have to revisit exactly how I do store it. Or make some sort of definition as to what constitutes a whole reference. But yeah, in Cinerella's like thing, it's probably going to have it in its database. It's probably going to have its own block of references that are cited, and it'll probably have, like, for example, an entity that is in fact this is probably going to be an actual integer. So it'll probably have an entry that's like 1231, and then within that entry it's going to have like all of the timestamps of all of the videos in which that is cited. So then that gives you a way to sort of, you know, you can easily display, obviously, where it's used. So you go on the website, and it'll be going through this block saying, this reference has this title and blah blah blah, and it's cited in, you know, XYZ videos. So yeah, that's basically the gist of that in terms of you know, relating things together. So yeah, the reference sort itself has relationships between just the entities, and then like the actual indexing side of it is going to have another set of like relationships for the places where it's cited. So yeah, so the threading, again, the idea was to bring them all together into the one program. So we'll have like Cinderella, this and this, all in the one program. And I'm going to have to work on the details, but I think that this client over here is kind of like, it's waiting for user input. So it kind of, I think it blocks on the read function or whatever it is. And Cinderella over here, meanwhile, is looking for like file system events. So stuff that, you know, when files change, is going to be responding to that. And I think that I'm going to have to be having different threads for those different things. I think I'm certainly going to have a separate thread for the user input, because that blocks, unless there's another kind of function that can do that. Let me just check actually what I'm actually using. Yeah, I think this is the one. So while we're running, we're going to be, get character, get ch is actually the thing, isn't it? So I think this thing is blocking basically until we get some input. So yeah, as I say, this will have to go onto its own thread, I reckon. And then I'll probably have another thread for, you know, like Cinerella's watching of the file system stuff, and then another thread for like the reference store bit, like getting the information between those bits. So that's kind of like the that's the rationale for doing this whole threading at all. So yeah, that was a bit rambling and possibly not even sensible, actually, to be honest with you. But I think it should come in handy. Should come in use, this threading, for this stuff. But if not, it surely will come in handy at some point. So yeah, what I'm going to do, I'm going to leave it here for now. Get a destination is fine. Cool. Yeah, I'm going to leave it here for now. And then the next, I probably will do some more streams on this, because I've only just started to learn threading, you see. So I still need to continue to go through the attributes. I might look at these man pages off stream, actually, because it would just be reading. And then I'm going to need to learn how to do mutexes and conditional variables. That was with Zilaresco's help, actually. He mentioned these things. And also semaphores, atomic stuff. Yeah, wants to look into that. And yeah, then I'll probably like mock up the various components I've got. You've got the Cinderella, got the reference store and the thing, and the client. I'll probably mock up like those things and just sort of just get a feel for how they might need to interact and how we will, coordinate the various bits of work between the things. So yeah, I will call it there. But it's been a successful first day, I reckon. First stream of 2022. First stream since 2019, actually. Or the first stream since 2020. Yeah, it's 2021 that I didn't stream. So yeah, we're getting back into it. I think everything worked. The video seemed to have worked. The mic seemed to have worked. The actual internet connection seems to have worked. No drop frames. I guess I am sort of flying by the seat of my pants a little bit because I'm still on Wi-Fi, and I do mean to actually get it all wired in, but sadly, it's a bit of an awkward setup because I'll just show you, man. I'll just turn the webcam around to show you what's what. So here's me, and here is the computer. You can probably see the computer coming into view just about now. So there's the computer, and then below the computer is the desk. So we've got a desk there, we've got the Wi-Fi antenna, and there's some stuff there. I'll just quickly show this little guy there. That's a gift from Chrono Dragon. He gave me that a while ago. And then over there is the router. So you can sort of see that, I don't know if you can see that there's floor between the desk and the router. There are my shoes. So yeah, the points are all over there. And the thing is over here. So I want to have, I'm going to get like a cable that goes from the socket down there along the thing, and it's going to meet that thing and basically join up with that and follow that through to the the computer, and then the computer and the PlayStation, because I've got a PlayStation. Can I show you that as well? I don't know if that's there's the PlayStation. You can sort of see that. That's down there as well. So I'll be able to like plug them all sort of together. Well, not together, but plug them into the router. But yeah, that was a bit of a whirlwind tour. Let me just catch up with what you were just saying before closing the thing. The rest of surgery threading here with multiple processes. Well, the first one could see others with 4, but I think it's definitely a good option. Maybe the better. What I want? That's a good point, actually. Yeah. Yeah. So where do I do that? I think I do multiple processes with something. It's not here. Could it be silken, maybe? It could be. Yeah, I think it might be silken. Oops. Yeah, it is. And the reason I've got this forking is that one of the forks does a periodically refresh call. So one of them initializes and handles the connections, and the other one periodically refreshes. You can tell that I'm inspired by Casey, by the way. Could you remove this junk? Like, it's definitely from Casey that I've got that word. Yeah, so, yeah, anyway, the point of that was just to say that I have at least used fork before. So yeah, initialization in one of the processes, and then periodically refreshing in the other. I can't really recall why why that's working like that. Yeah, I will just make a note though that the forking could be another option, because I hadn't actually considered that. Use forking interval just so the domain trophy is across the. Ah, yeah. Yeah, so the main parent basically does nothing that could crash. You know, it's like super. It's just going to work, basically. Yeah, I will just make a note. What would it be? The multiple. Sits there waiting. Yeah, right. Yeah, cool. So that's similar to the Pthread join, isn't it, really? Because this is essentially waiting. I suppose apart from... Ah. I feel like PIDT was something that I encountered today in the threading stuff. Yeah, what I want to look for here is whether it's done in a loop, basically. Where's the call to wait? There we go, wait PID. So the example doesn't actually call wait, is that right? What am I looking at? I'm looking at the thing for wait, aren't I? Oh, so it's all three. So wait only takes W status, whereas wait PID takes the PID and the W status and the options. Okay, the call wait W status is equivalent to this. Yeah, okay. That's fine. Yeah, so wait PID. So yeah, it's done inside a loop. Yeah, so I think, if my understanding is right, oh, mind you, no, because this is going to, I assume it blocks, doesn't it? Yeah, this does seem to block, doesn't it? So it's basically exactly the same as the other guy. No, that's cool. Yeah, yeah. Let me see what I have actually got, because I have changed that etc. man page manpath conf. Possibly that actually. Yeah. So you're saying put 2 before 1. So not when 2 become 1, but 2 before 1. Yeah, let's do that. Oops. God. So, I wonder if that just takes effect straight away. Yeah, nice one. So there were no more options. Yeah, cool. Alright, yeah, so it's definitely time to call it a day, I reckon. 2 hours 39 and counting. 10 to 6. Yeah, I'll just go and buy some noodles and whatever. And I'll probably come back and do it all again tomorrow, I guess. Yeah, so it was a pleasure. It was cool to be streaming again. Thanks for popping by, guys and gals, and everyone in between. And yeah, we'll reconvene at another time. So thanks again, and laters.